Here we're given two functions, f of x equals 3x minus 2 and g of x equals x plus 2. And if we were told to do f times g, we would simply multiply the two functions, 3x minus 2 times x plus 2. And the way to do it is we'll take the front one, or the first one, multiply with the first one, where we get 3x squared. And then we'll take the 3x once again and then multiply to the 2, where we get 6x. And then we'll take the negative 2, multiply to the x, negative 2x. And then lastly, negative 2 times positive 2, negative 4. And if we simplify that, we end up getting 3x squared plus 4x minus 4. However, if we have f of g, so the difference between f multiplied g and f of g, the composite function, is that when we multiply, notice it's a closed circle, whereas when we're doing the composite function, or f of g, it's a open circle. And if we write that f of g in a different way, it would read f of g of x. And once again, if we change that, it would become f parentheses g of x close parentheses. So in this case, it would become f of, inside the parentheses, I'm going to write down what g of x equals, which is x plus 2. And then to do f of x plus 2, we would take that x plus 2, or the g of x function, plug it into the x of the f function. So we'll take that x plus 2, plug it into the x right there, where it would be 3 parentheses. So what I like to do is, where we see the x, where we're going to plug in the x plus 2, I like to just leave a pair of parentheses and then write out the rest of the equation. And then at the end, inside the parentheses, I'm going to put in the x plus 2, where the x was of the f function. Like that. And then if we simplify this, this will become 3x plus 6 minus 2, or 3x plus 4. Next, let's try g of f, which could be rewritten as g of f of x. Then we could rewrite this once again as g of f of x, where we'll go ahead and first replace that f of x in that parentheses, where f of x equals 3x minus 2. So we'll go ahead and put that in here. Again, substitute or replace the f of x with 3x minus 2. Then, to take the g of 3x minus 2, we take that 3x minus 2 and plug it into the x of the g function, where, as I did it before, where the x is, I like to go ahead and just go ahead and put in the parentheses, plus 2, like we had here. And then at the end, I like to go ahead and take that 3x plus 2, put it in the parentheses. What we're doing is, once again, replacing that x of g of x function with the 3x minus 2. Where if we simplify this, we end up with 3x. Here's another example. If we have f of g of 2, this time instead of using the x that we've been using, let's go ahead and use a number. We could rewrite this as f of g of 2. So we'll go ahead and leave the f function alone, and then let's go ahead and find what g of 2 would be. To find g of 2, we take the 2, plug it into the g of x function, meaning g of 2 would be, put the 2 into the x, so we get 2 plus 2, or 4. So we'll go ahead and, instead of the g of 2 that we have here, we'll put in 4. And then once again, to find f of 4, we'll take the 4, plug it into the x of the f of x function, where in this case, it's going to be 3 times 4 minus 2. Once again, put the 4 where the x is of the f function, where this will equal 12 minus 2 or 10. And as our last example, let's do f of 3. So again, we could rewrite that as f of, that's for the first f. Then the f of 3, we'll put that in the parentheses like so. Then we need to first go ahead and do the f of 3, meaning take the 3, plug it into the x of the original f of x function, and f of 3 would be 3 times 3 minus 2 or 7. So then this will be f of, once again, that f of 3, we just worked it out up here, and it equals 7. So it's going to be f of 7. Then to finish it up, this is going to be take the 7, plug it into the x of the f of x function, where it's going to be 3 times 7 minus 2, or simply 19 as the final answer. So in this lesson, first I gave you an example of the multiplication of two functions to show you the difference between the multiplication and the composition of functions, and how to rewrite the f of g into f of g of x. In the end, simply equals f of g of x.